Very good morning. Actually, today we will solve some important question in exercise 2A, which is exactly given in a schema of a book. So now we can start. Question number 9. The question is given, let Z be a complex number such that an amplitude of Z minus I by Z plus 1, this is equals to pi by 4, show that the points Z, the point Z lies on the circle, in the complex plane. So this is exactly the question paper, which is the question number 9 in the Mapa book. Now we are trying to solve the solution. In every question, you will see one thing: what is exactly given, the given information, and what we have to prove. So here the given information is given. Z is a complex number such that amplitude of Z minus I, amplitude of Z minus I quota by Z plus 1, this is equals to pi by 4. Star marks. So we have to prove that. Z lies on the circle in the complex plane. How will prove? First we take Z as x plus iy, where x comma y both are real number. Then you need to calculate Z minus I by Z plus 1, and that will be x plus iy minus I by x plus iy plus 1. So that means just you write it in the form of a plus ib, it will be x into x plus 1 plus y into y minus 1 by x plus 1 whole square plus y square plus y minus 1 into x plus 1 minus xy by x plus 1 whole square plus y square. I have already done this calculation in the previous video. That is similar kind of thing, but this ratio is where there is basically purely imaginary. Now the amplitude of Z minus I by Z plus 1 equals to pi by 4. So according to the given condition, amplitude of Z minus I plus by Z plus 1 equals to pi by 4. So therefore tan pi by 4, this will be y minus 1 into x plus 1 minus xy by x into x plus 1 plus y into y minus 1. Here just we have assuming the amplitude is principal amplitude. So actually, what is the recall here? We have used one recall. If z equals to a plus ib and amplitude z equals to some theta minus pi less than theta less than equals to pi, then tan theta equals to by. We have used this result and we get tan pi by 4 equals to this. So that means xy minus x plus y minus 1 minus xy, this is equals to x square plus x plus y square minus y. So just you calculate it, you will get x plus 1 is whole square plus y minus 1 is whole square equals to 1, which represents a circle with center at minus 1 1 and radius 1 unit. So here actually we solve it. Z lies on the circle in the complex plane. So minus 1 1, that means like that, and the circle is here. This is the point is minus 1 1, center and radius is basically 1 unit. So therefore Z lies on a circle in the complex plane. So proved. Now we'll move to the next question, question number 10. And it is given Z is a variable complex number. A variable complex number such that mod of z minus I by z plus 1, this is equals to k, so that the point z lies on a circle in the complex plane if k not equals to 1 and z lies on a straight line if k equals to 1. So we'll move to the solution. So what is given? It is given that z is a complex variable such that mod of z minus I iota by z plus 1, this value equals to k. What we have to show? So we have to show that first Roman 1, z lies on a circle in the complex plane if k not equals to 1, and Roman 2, z lies on a straight line if k equals to 1. So these two things we have to show. So how we'll prove? Let z equals to x plus iy. X and y both are real number. Then mod of z minus I by z plus 1, this will be equals to k. That implies x plus iy minus I, x plus iota y plus 1 that modulus equals. Just I put the value of z. So it will be x plus I y minus 1 by x plus 1 plus iy. That modulus will be k. Next we will just I y minus 1 x plus 1 minus iy by x plus 1 plus iy, x plus 1 minus iy, that modulus will be k. Now just after simplification we will get x into x plus 1 plus y into y minus 1 by x plus 1 whole square plus y square plus I y minus 1 into x plus 1 minus xy by x plus 1 whole square plus y square. Just we make the form capital A plus IB pattern, that is equals to k. Now we know the modulus A plus IB, modulus is root under square plus b square. So from this we can write it as x into x plus 1 plus y into y minus 1 by x plus 1 whole square plus y square, that quantity square plus y part, that means y minus 1 into x plus 1 minus xy by x plus 1 whole square plus that whole square equals to k square. Just we are squaring both sides. So this will be x into x plus 1 plus y into y minus 1 whole square plus y minus 1 into x plus 1 minus xy whole square. This is equals to k square multiple x plus 1 whole square plus y square. Just you will expand all this expression and we will just solve it in the form. You will get x plus 1 whole square into x square plus y minus 1 whole square plus y square y minus 1 whole square plus x square. This is equals to k square into x plus 1 whole to the power. So now actually we will do one thing. Here the calculation will be so big. So from that, the actual solution, for the actual solution, it will take more time. So one thing we can just start from this expression. Okay, you can do the way which we have tried to solve it. But if you start from this expression, so from this expression you will write it in the form the x plus I y minus 1 by x plus 1 plus iy, that modulus equals to k. So here you know mod z1 by z2, that modulus will be mod z1 by mod z2. That formula you can use. And you will get x square plus y minus 1 whole square equals to k square into x plus 1 whole square plus y square. That will be more simplified form. So from this you can write x square plus y square minus 2y plus 1. This will be k square x square plus 2x square plus k square plus k square y square. Then you will just simplify it and you will write x square into k square minus 1 plus y square into k square minus 1 plus 2x square plus k square minus 1 plus 2y equals to 0. So just you will take it double star. Now you just consider one thing from here. Let first case 1, just to consider k not equals to 1. Then obviously it represents a circle with center k square by k square minus 1, 1 by k square minus 1. Why it is basically circle? Since coefficient of x square, this is non-zero, and obviously this coefficient equals to coefficient of y square, and this is also non-zero. This is the first, the coefficient of x square equals to coefficient of y square, and you will see one important other important condition for to be a circle, the coefficient of xy, that part is also 0. So that means it represents a circle. And if we think about k equals to 1, this is our case 2. So in this case, from 1 we get 2x plus 2y, this is equals to 1, and this implies x plus y equals to 1, and which represents a straight line. So it will be 2x plus 2y equals to 0, so x plus y equals to 0, x equals to minus y. So this is basically straight line, x equals to minus y. So that means we have proved two cases here. We have first proved if k not equals to 1, the expression is basically represent a circle, and if k equals to 1, it represents a straight line. So in the question paper 8, 9 and 10, what we see, we just make a summarize, or you can say the comment or conclusion. The conclusion is like that: the ratio about z minus I by z plus 1. If it is purely imaginary, just you think about this ratio. Here the ratio is like this number, and on the basis of this ratio we will conclude if the ratio is basically purely imaginary. That means it is in the form of IB, যেখানে B, where B not equals to 0. Then it basically represents, that imply Z lies on the circle in complex plane. Again, the second case is the amplitude of z minus I by z plus 1 equals to pi by 4. This also represents z lies on the circle in the complex plane. And if modulus of z minus I by z plus 1 equals to k, on the basis of k, if k not equals to 1, it represents a circle, and if k equals to 1, it represents a straight line. That means z lies on a straight line. So this is the conclusion. You need to recall these three kind of cases for the ratio z minus I by z plus 1, and these are the conclusion. So thank you so much, and from this you can expect